Okay, so I wanted to show you some new things that we're doing, some interesting things, give you a feel for sort of all the new technologies that hit our jobs and how we have to react and change. So I think everybody probably talks about drones, so I'm going to give you some examples of how we actually use drones today and how it impacts what we do. So we, 5 years ago, we never flew drones. Today we actually have jobs at our research station that their job is to fly drones for us. That's pretty much what they do. It's a huge change. We didn't have that position 5 years ago, and today, somebody can be, their whole job is just to go fly drones over fields. So we fly these big drones here. This would be an image that probably shows up good on the screen over here, but that's a soybean field that's in the stages of maturing, so you've got some green, brown, all that type of thing. So we fly that drone. We fly it every 3 days for about 2 weeks. And so the first flight's all green, the next flight, a couple of them start turning yellow, and then there's just a progression into brown. And so you feed all that imagery into a computer, and it cuts it apart. So if you can see this blue grid that's on this image, that's a plot. So that brown plot, that's a different variety than the neighboring one that's green. Okay, and the computer knows that, and it knows the GPS location and all that stuff of that plot. So you fly it 6 times every 3 days, and the computer cuts all that imagery up, and it can show you this composite image on the right, which is the same exact plot every 3 days over 2 weeks, and it shows it being green, and then yellow, and then quite a bit of brown, but still some yellow leaves in there, fully brown, and then harvest mature. So it gives you that progression of green to brown. The computer analyzes all that data, and it'll actually give you a maturity score. It'll say that's a 3.7. Before, we would walk each of those plots, and if you know about walking soybeans when they're green, that means you wade through all those soybeans, and you say that one, that maybe 6 days that'll be mature. You wade a little further, that one's today, and you would rate those. I could only get through maybe, 2,000 plots I could take good maturity scores on. This drone can give me maturity scores on 15,000 plots in no time. It's not a big deal. So we can fly a whole bunch of locations for this and get data where there's no way 6 of us could have waded through that many soybeans and assigned scores. So huge game changer. We get a ton of data for really cheap now. So that means our data is a lot better and we can get a lot more of it. Iron deficiency chlorosis, this is more just an example one, but same type of deal. The drone flies this and can assign brown to green scores. I wanted to bring this one up because this one isn't hard to do physically. As a brain, you just walk through and assign scores. It's not that big a deal. But we would never go back and score it every 2 days, right? That's quite a bit of work. But we've done that with the drone now, so we actually get a recovery. We never scored this for recovery, so a lot of times you'd assign a score of a 4 or a 5. You'd never go back to that field and see it. You just said that's a 4 because it's yellow. Today, we fly the drone multiple times and we can see some of these 4s actually recover and are just fine 3 weeks later. We never would have known that, but the drone is able to take that data and show us that. So, we can use this drone to actually get data that we couldn't get before. Next generation type stuff. This is really exciting, but pretty preliminary. So this is an image of something called LiDAR. I know you guys all drive self-driving trucks at this point, but people talk about self-driving cars, right? Those have a LiDAR, which is laser radar, strapped to the top, and it can sense distance. So we took a LiDAR, strapped it to a drone, and fly over a soybean field. And every time the laser hits a pod or a bean or something and bounces back, it knows how distance lies. So it can give you a 2D image of your field. So we fly this drone through the field, and you can see those are soybean rows, right, in red. Those are the soybean rows going down the field. So then these 4 pictures on the right, if you were to look down those soybean rows, like at plant level, right, dead on, that's what you see in this right image, 2-row plot. And so on the right, you see lodging severity of a 9. You see a whole bunch of dots at the top. That's that laser hitting a standing straight up soybean. You can actually see it at the top. At this one at the bottom, lodging severity of 3, you see that laser got to go a long ways down to the ground before it finds a soybean. That's that soybean just sort of piled up on the ground. It's not what you want to see. So you can actually detect the physical layout of a soybean plot now with a drone. This isn't fully deployed yet, but give us another year or two, and this will be standard operating procedure for how we do a trait like logic. Really, really interesting stuff, and really the cutting edge of where we're going and how we operate. Another interesting piece I wanted to talk to you guys about, Kansas. You know, you got some pretty decent soils here, but drought can definitely be an issue. Drought's a trait that I've long worked on and been long frustrated by. It's really difficult, it's really complex. But some of the cool stuff we do that's out of our normal operating stuff, you get interested by science, you just dig in and figure it out, is thermal sensors in canopy temperature. So we had a project where we hooked up some thermal sensors, and it measures the canopy, the temperature of each variety in a plot. And the temperature is relative to how much water that soybean's spending, right, on cooling itself. So some varieties like to be cool, so they set their thermometer, at 68, right, and they spend a lot of water to stay cool. Other soybeans say, no, 78 is where I like to be. And they spend less water, and they're more conservative on where they spend their resources. We can measure that by just checking their temperature. So we've got these poles and these sensors, and they're measuring these plots. So you can also buy a thermal camera for a drone. So we did that, and we fly this field. It probably shows up here, but there's a shadow cast across each plot by that PVC, and it's a 3-inch shadow. This 3-inch PVC. You can actually see that shadow cast in each of these images. So that drone's able to pick up a tiny shadow going across the plot. It's really, really quite sensitive. And so the data that we found out of this was a relationship between this trait. You don't need to understand it, but it's when it's really hot and not very humid. That means the plant, there's a lot of water that's demanded from that plant. When it's with low humidity and hot, that plant needs to cool itself a lot, right? And so what you see here are different varieties down here at the bottom, and we're checking their temperature. And it turns out some of them have their air conditioner set down to 68, and some of them are at 78. And over time, that difference is a lot of water that they either do spend or don't spend on cooling themselves. And turns out from this data, I don't know if I have another slide, no, is the ones that are pretty conservative are the Western products that we select. And the ones that spend a lot of water on cooling themselves, those are usually Eastern products that don't do quite as well. And so this data has been really interesting. It's sort of validating how we do product placement. And it makes sense, right, that as you move west, varieties really need to conserve water in order to make it through the summer. So just some cool science that's coming this is what really keeps me interested in what I'm doing. A couple things I'll probably just go through real quick here, save it for questions, but we're using power planters now. We used to actually dump packets, right? 2 guys would sit on the back of the planter and dump packets all day to get our plots in the ground. Today we don't even do that. We put them in these clams with these 2D barcodes on it. We put them in these things called magazines down here. And we go through a plot. Everything's already set up in the field. There's 1, 2, 3, 4 magazines on that planter on the left there. And those magazines just automatically plant. So a guy gets in, drives the tractor, the GPS unit knows where he's in the field, and it plants the plots for him. So it's really accurate, and we have a lot less mistakes in the field. We thought we were good before, but then when we moved to this, you realize, yeah, we did sort of miss dumping a couple of those packets here and there. New plot harvesters. I think I'll wrap up more with this, where all the work we do, the genetic gain that we build into these base genetics really shows up in something like this. A-series soybeans against competitor soybeans, and just the yield advantages that we're seeing. Our genetic gain engine is really good, and it's really fast, and it's really starting to show up. And that's really nice to see. These are yield gains that I absolutely did not have when I started in 07, and we do have them now. So it's just proving that what we're doing is working, and it's making a difference in your fields. I can skip through this, just a snippet of some of the literature I'm sure you've seen, but just really amazing yield advantages for products that it's sort of hard to imagine that we could have had, approaching 4 bushels on some products, but it's fantastic. Traits, it's maybe a big question, big topic, but really my job as a breeder is to deliver genetic gain. Whatever trait packages you guys need in your operations is what we'll sell those in. And so right now we've got Extend, we've got some Liberty, but Enlist is a big topic in the future, as well as Extend Flex once it gets on the market. You know, whatever fits your farm is what we're going to do. Genetic gain is really what I'm after, and the traits are, help control weeds. It's exciting stuff coming in different trait packages in list, and so that's definitely going to be a topic that's going to be talked about quite a bit in the future, and we've got a lot of stuff coming in the pipeline for that as well. Wrapping up though, I think this is a graph, take USDA on-farm data, right, from nationwide every year from 1920 up to 2020, it's 2019 probably, and you draw some lines. So when I started in 07, you could really only draw one line, and that was about 1/3 of a bushel per acre per year. That's how much genetic gain was realized on your farm. So was that 1/3 bushel per acre per year. As I've gone on though, you can actually start drawing multiple lines. And so you've got this line which seems to stop in the mid-90s. There's a second line here which would be the Roundup era, which still about 1/3 of a bushel per acre per year, but we got a bump when we went to better weed control, right? With all the Roundup varieties, weed control was better, and all of a sudden on-farm yields just took sort of a jump. What we see in the last 5 years is just a rapid gain. These triangles here. About 1.4 bushels per acre year in the past 5 years. Now, whether that continues, I don't know, but it just shows you the rapid gains we've made really recently with genetics and new trait packages. So that's what's really exciting to me is keeping that going. So I guess leave you a couple things. My group, R&D, we're really focused on increasing the rate of genetic gain. That's really what we're passionate about. We're committed to giving you access to technology options, but genetics is really what pays the bills. And so select the right trait package that matches what you need agronomically, and then as well as the weed spectrum you're trying to control and what you're comfortable spraying. So that's it. I'm sure I've got some time for questions, I hope. So anything you guys want to ask, I will attempt to answer.